Welcome, everyone. Okay. And it is my pleasure to introduce our first keynote speaker, Marco Passarotti from the Catholic University of the Sacred Heart in Milan. Marco had a classical education leading up to linguistics and a PhD in communication sciences here from the University of the Italian-speaking Switzerland, USI, which also shares this building. After his PhD, which was in 2004, he moved to Pisa in Tuscany, in Italy, where he joined the Institute for Computational Linguistics at the Italian National Research Council. After that, he joined the faculty of the Catholic University of the Sacred Heart in Milan, Italy, where he now holds a full professorship. He also founded the Circe Research Center. It's an interdisciplinary research center focusing on computational linguistics. He directs a new program on computational linguistics, which is just starting this year. And most importantly, he is an ERC grantee, that's the European Research Council. Marco received a massive ERC grant for the LiLa project. LiLa stands for Link in Latin, and Marco will tell you more about it. He's not here with us in person, but is very much with us in spirit. So without further ado, ladies and gentlemen, here's Marco Passarotti.
Thank you very much, Daniele. Thank you very much. I'm really sorry that I cannot be there with you. I really must say I cannot be there because I was found COVID positive last week at a conference in Spain. So I spent the first 3 days of my positivity there. Then I got back to Milan and I'm still stuck at home. So I'm still positive, so I cannot join you there. I would love to win a Toblerone, and I would love to participate in the battle of NLP ideas. It is something that sounds very exciting indeed. And let me thank very much the organizers for inviting me today to give this talk, because it is pretty moving for me. I had my PhD from USI just on the other side of the street there, and some 20 years ago. And I perfectly remember when the place where you are sitting now was a parking lot. And I used to park my car there to attend some courses at USI to prepare myself for the PhD. So it would have been really great and exciting for me to be there after all these years, and see that parking lot became this wonderful campus where you are now. And talking about interaction between people that was mentioned during the opening, I will talk about, during my talk, something about interoperability. And interoperability will be a keyword today. Now I'm going to share my screen in order to show you my slides. Please tell me if something is wrong and you cannot see the slides. So if I won't hear from you, this means that the slides are working well. Now I'm sharing the screen. And so I said that I will talk about interoperability between linguistic resources using the linked data paradigm. So no more separate silos. Already in this title, there is a number of keywords that I will deal with during my talk. So linked data, interoperability, and linguistic resources. And the talk is organized as follows. I will first of all talk about the problem and the possible solution to the problem of data sparsity, of separate silos for what concerns linguistic resources. Then I will show you an example where the application of linked data to linguistic resources hopefully works, which is the LiLa Knowledge Base about Latin. So we will talk a bit about Latin, and I'm very glad that the organizers wanted to invite a classicist, basically, as to give one of the keynote speech of Swiss Text this year, also to show the real interdisciplinary approach of this conference and this community. And finally, I will sketch a number of challenges and my hopes for the very near future, and in some way already the present. So the problem is something that I dealt with for several years, and suddenly I realized that several colleagues had the same problem. The problem is that over decades of empirical research in linguistics, and in particular in computational linguistics, we have built a lot of things for many languages. And these things are resources. So textual resources, like a corpus, lexical resources, like a lexicon or a dictionary, and we have a lot of this, and natural language processing tools. This was done for Latin, but for many languages, as you know. And here the problem, which raises the research question behind the movement of applying linked data to linguistic resources to make them interact, is that these resources and tools are currently scattered and unconnected. And people get crazy to find the resources, but most of all, to make them interact, to reach interoperability between distributed resources. So one of the solutions, and probably today the most pursued solution found in the community, is what is proposed by the Linguistic Linked Open Data community, which is basically a movement about publishing data for linguistics and natural language processing. So basically publishing linguistic resources and natural language processing tools by applying the linked data principles with the aim of making linguistic resources interact with each other. So here I mentioned the linked data principles. So just a few words to recap what the linked data principles are. So applying the linked data principles to our data, linguistic data and linguistic metadata, has the aim to make the resources interact and to make them fair. I won't have time to enter the details of what fair means, but most likely you already heard about this acronym, which is very important today, and which means that your data and metadata must be findable, accessible, interoperable, so these keywords come back, and reusable. And applying the linked data principles to linguistic resources makes linguistic resources fair. So what are these linked data principles? First of all, that you have to use URIs for things, so the uniform resource identifiers. So what are URIs? I think that in this audience, most of you know what a URI is. It is a unique and persistent identifier that identifies the things you deal with. So like your genetic code, in Italy we have the codice fiscale, something that identifies you uniquely and persistently throughout all your life. So for things, this is pretty generic. The things we deal with here are linguistic things. So an entry in a lexicon, a token, so an occurrence of a word in a corpus are the things we deal with. And we assign to all the things that we deal with these URIs. Then we use HTTP URIs to allow people and machines to look at things. So basically, we publish these things uniquely and persistently identified on the web. Then we use web standards to represent and query the data and metadata of our linguistic resources, such as RDF and SPARQL. I think that many of you know about RDF, Resource Description Framework, and SPARQL, which is the query language used to query the semantic web and linked data. And but just to say a few words about this, which are important about RDF. RDF is the data model behind linked data, and it is based on the idea of triples. So everything is represented to triples: a subject and an object, and the relation between the subject and the object. And this relation is represented by a predicate that is technically called a property with two arguments, the subject and the object. So in this case, for instance, I am a subject, and Swiss Text 2022 is an object, and there is a relation between myself as the subject and Swiss Text 2022 as the object, and this relation can be represented by a property called is a speaker of. So Marco Passarotti 1 is a speaker of 2, Swiss Text 2022 3. And this property and the properties used are described in formal description of what is out there, which are ontologies, and I will come back on this. And finally, you include links to other URIs. So you build the relations, the network between the things you deal with in order to make interoperability happen. So there are several benefits of applying linked data to linguistic resources. I just mentioned here a number of these benefits. The first one is a benefit of representation and modeling, because RDF is a very versatile data model to represent those things we deal with every day with our annotated corpora, for instance, like standoff annotations, or NLP, like dependency parsers. Second, structural interoperability. This is a technical term originally introduced by Nancy Hyde and James Pustoyevsky, and structural interoperability is technically defined as the ability of different systems to process, exchange data either directly or via trivial conversion. So what does it mean? This means basically using a common data model like RDF, consisting of shared protocols and data formats. So we use the same structure, the same syntax in order to support interoperability. In this case, we use the same data model, RDF, and protocols of publications like HTTP. Then there is conceptual interoperability. If you remember the example, Marco Passarotti is a speaker of Swiss Text 2022. I mentioned the fact that a speaker of is a property defined in some ontology. Okay, conceptual interoperability, which is also called semantic interoperability, is the ability to automatically interpret, exchange information meaningfully. So you listen to semantics in order to produce useful results. This means using a set of common linguistic data categories defined in ontologies. So we use the same, let me say, the same language. We make the linguistic resources that we want to make interact speak the same language, use the same vocabulary to understand how to use the URIs and how to interpret semantically the relation between a subject and an object, the relation between myself and Swiss Text 2022. Federation. You can combine information from physically separated repositories, which are interlinked. And dynamicity. You can always provide access to the most recent version of a resource, which is maintained by the data provider. And ecosystem. There is a large and active community and which is trying to build common tools and practices. There are several telcos every week in the community of Linguistic Linked Open Data where we meet and discuss about, for instance, how to represent derivational morphology. Well, to represent means to find a formal way to represent what is there. So to build ontologies and data categories. We are in this phase of building this common language that hopefully will be spoken by distributed linguistic resources to make them interact. So now let's move to an example where hopefully the application of linked data to linguistic resources works, which is the LiLa Knowledge Base. Well, this is about Latin, but it is not needed that you speak and understand and read Latin. because everything in LiLa, or almost everything in LiLa, is pretty language independent. And the architecture of LiLa, even if it is highly lexically based, it is language independent. So the LiLa Knowledge Base. The LiLa Knowledge Base is the result of this still ongoing ERC Consolidator grant, which will end next year, and it is defined as a collection of multifarious, which means different kinds of interoperable linguistic resources described with the same vocabulary for knowledge description. So by using common data categories and ontologies, which is what I said. So these resources are described using a common language. They speak the same language, which is based on the linked data principles. We start from the assumption that interlinking is a form of interaction. So we interlink resources to make them interact. And here, sorry for this, I'm a linguist, prefixes matter, because today we have great places where to store resources like infrastructures. The most important one that you for sure know is CLARIN, which is an infrastructure, while LiLa aims to make it possible interoperability. You listen to the difference between these two prefixes, infrastructure, which is internal, and interoperability, which is distributed. And I will come back on this difference between infrastructure and inter something during when I will get to the conclusions of my talk. So the architecture of the LiLa Knowledge Base to make the distributed resources for Latin interact is very, very simple, and it is highly lexically based. As you can see here in this part, in the bottom part of this slide, you have the data providers, which are our resources and tools. So lexical resources like the WordNet, a Valency lexicon, a dictionary, are made of lexical entries. When you open a dictionary, you find lexical entries. Textual resources like a digital library and annotated corpus are made of tokens, are made of occurrences of words. When you open a textual corpus, you find texts, and texts are made of words. And then there are natural language processing tools, which provide natural language processing outputs. You see this double arrow here because the output of a specific kind of NLP tool, you know about it, a tokenizer, are tokens. And tokens on their side, on their turn, are the input of other NLP tools, like, for instance, a part-of-speech tagger. But what is important in LiLa, and this is the reason why this node is pretty big, is that all these components are made interoperable by passing through the lemmas. So, for instance, in LiLa, you can search for all the occurrences of a specific lemma in a number of distributed corpora. So you are using together at the same time different corpora to making them interact. But there is something more. You can search for all the occurrences in, let me say, 5 different corpora of all those lemmas that show some specific lexical properties which are provided by the lexical entries of, let me say, 2 different lexical resources. So you are using together and you are making interact a number of lexical resources, in particular information taken from different lexical resources and information taken from different textual resources. So the good news is that we already have all this information at hand. We have these resources. The next step is to make them interact. Just like when I talk to classicists, I say, I don't want to really change your everyday work, but to make it better. Because classicists are used to have on their desk a dictionary, a lexicon, a collection of the works of Cicero, and a collection of the works of Thomas Aquinas. And their work consists in making them interact. To search in a dictionary some words that then they are searching their occurrences in the text of Cicero. Is to make resources interact. And today we can do this by exploiting the digital resources that we have built. So, given the important role played by lemmas in the LiLa Knowledge Base, the LiLa Knowledge Base has its core in the so-called Lemma Bank. So the Lemma Bank, which is described using this de facto standard for publishing lexical data as linguistic linked open data, which is called Ontologies Lemon. So what is the Lemma Bank? The Lemma Bank is a collection of lemmas for Latin, is a collection of citation forms used for Latin. So we spent the first 2 years and a half of the ERC project building this collection of around 200,000 lemmas for Latin. And you know, my friends always joke with me and say, well, they gave you 2 million euros to just build a list of words? Really? Are we spending this way our money? So, well, it's not so trivial, but it's very important to do it very well, as the best that we can, because the Lemma Bank, this big collection of lemmas, is the very core of LiLa, because to the Lemma Bank are attached the tokens from textual corpora and the lexical entries from lexical resources. So, how it is built? Ontologies Lemon is made of classes. I will just detail a couple of classes. The most important class is a lexical entry. So a lexical resource is made of lexical entries. And the lexical entry can have one or more lexical forms. So for instance, in Latin, a lexical entry like rosa has a number of inflected forms, like rosam and rosae and rosarum and rosis. Like in English, for go, you have go, going, went, and gone. One of these inflected forms is technically called the canonical form. The canonical form is the inflected form of a lexical entry that is canonically, conventionally used to represent the lexical entry in resources. So nothing but the lemma. So the Lemma Bank of LiLa is basically a collection of canonical forms of Ontologies Lemon. So we built this collection. In this part of the Ontologies Lemon ontology, you have the semantic part. A lexical entry can have one or more senses. A polysemic word has more meanings, which are different senses. And these senses are the lexicalization of a more general meaning, which is called the lexical concept. To understand the difference between these two, a lexical sense is a specific sense of a word, while a lexical concept can be, for instance, a synset of wordnet. And indeed, it is a synset of wordnet, and I will come back on this when I will show you in a while the lexical resources linked to LiLa. So keep in mind that there is this big lemma bank, which is the core of LiLa, and it is a collection of lemmas, canonical forms. And let's start from how lexical resources are linked to LiLa. And let's move, here you should see my screen, to this data sheet. So this is the data sheet, so the collection of triples for this subject. The subject is admirer, which means to admire, and it is one of the lemmas in the Lemma Bank of LiLa. And you see here the triples. So this subject with this URI, unique and persistent identifier, is related to this object, verb, by this property, this predicate, as pos. So in other words, in informal words, we are saying that this subject, which is admirer, has the part-of-speech verb. So admirer is a verb. Okay, now from admirer, we can see with a graphical representation in terms of network, some of its relations to lexical resources. And let's start just from the Latin wordnet. And I talk about this because there are wordnets for many languages, and the representation of wordnet as linguistic linked open data is now pretty stable, and we just follow what is there. So what is the difference between these two nodes? So this is the the lemma in the lemma bank of LiLa. So this is a canonical form talking about in terms of ontolog's lemma. And admirror has two graphical variants, admirror and unmirror. This is instead the lexical entry. So ontologically speaking, this is a lexical entry of ontolog's lemon for admirror in Latin WordNet. And these two elements are connected, are interlinked by this property, which is canonical form, which is described by the ontolog's lemon ontology. So you see here our lexical resource made of lexical entries is linked to LiLa. Lexical entries are linked by canonical form to the lemma in the lemma bank. Okay, this is a lexical entry for the Latin WordNet. And the lexical entry for the Latin WordNet is made of the belonging of a lexical entry to a synset. You know how WordNet is made. WordNet is a collection of words of lexical items which are organized into synsets, which are sets of conceptual synonyms, like something like this. So, admirror evokes a lexical concept. This means this is the ontological representation according to ontolog's lemon of admirror belongs to this synset. This synset is the synset which means regard highly, think much of it. And this synset is evoked by, which is the inverse property of evokes, by a number of lexical items, lexical entries of WordNet. So this means that estimo and amo and pono and again here trovo and some other words in the Latin WordNet belong to this synset. And each of these lexical entries is linked by canonical form to the lemma bank. You see also the color here. So this is the lemma aestimo, aestumo in the lemma bank, just like admirror and unmirror is a lemma of the lemma bank. So what can you do here? You can write a SPARQL query that passes through these triples. These are triples, a subject, an object, and a property, and the relation between them. So here you can write a simple SPARQL query that says, oh, give me all the occurrences in all the corpora linked to LiLa of those lemmas that have a lexical entry in the Latin WordNet that evokes a specific synset. So give me all the occurrences in my corpora of all the words that in the Latin WordNet belong to a specific synset. So have the meaning, regard highly, think much of it among its meanings. So this seems to be trivial, but it's not, because here you're using information taken from different resources, the corpora and information taken from the Latin WordNet. Now let's get back again on admirror. Just a moment here. Okay. Let's focus on admirror. Admirror is linked in the lemma bank by the relation, by the property as base, to this node, which is the base of mirrors. This node is just a connector of words that in the lemma bank are derived from the same lexical basis. In other words, here you have words like mirror and miraculum and mirabundus and what else? And mirus. So all those words in the lemma bank that share the same lexical base. What can you do here? Give me all the occurrences in my corpora of all those words that has the same base. And you are collecting information from corpora and lexical resources. Again, let's focus again on mirus, and let's see an example of another resource. Unfortunately, I don't have much time to enter all the resources, but I want to show you this one. So now you perfectly know that lexical resources are linked to LiLa by canonical form from their lexical entry. So this is the lexical entry mirus in the etymological dictionary of Latin by Devan 2008. So if you open this etymological dictionary and you go to the lexical entry for mirus, you will find the etymology of mirus. And we modeled etymology using a specifically built ontology that is called Lemoneti, which assigns etyma to an etymology. So mirus as an etymology. This etymology has two etymon. In other words, these are roots. So this is the Proto-Indo-European root used in mirus, and this is the Proto-Italic root used in mirus. And you also have an etymology link, which says that this is the source and this is the target, which means that Proto-Italic root is the target of a link, or resource source is the Proto-European root. So Proto-Italic derives from Proto-European, Indo-European, and there is another etymology link from Proto-Italic to Latin. So you move from Proto-Indo-European to Proto-Italic and finally to Latin. This is a way to represent the lexical information stored in the etymological dictionary in terms of linked data. Again, with mirus, we have another lexical resource which is called Latin affectus, which is used for sentiment analysis of Latin. Latin affectus basically assigns a prior polarity to the words, so positive and negative. Mors has a prior polarity negative, that, and amor has a prior polarity positive, which is love. So, for instance, mirus has a prior sense, and this prior sense, which is represented with an ontology that is called marl, has polarity positive. And to this positive node are linked all the words that are assigned a specific positive sense in different resources, Latin affectus and the Latin wordnet. So you can query your data and search for all the occurrences of the words that are assigned a positive polarity in Latin affectus, and you are joining information from different resources. So getting back to our presentation, we have seen lexical resources. Now let's see the other kind of resources stored and linked in LiLa, which are textual resources. And here I just report a very simple example from the largest Latin tree bank. A tree bank is a syntactically annotated corpus for Latin, which is the Index Domesticus tree bank, which is the corpus of the writings of Thomas Aquinas, and it is an historical corpus in the story of computational linguistics, because it was the corpus on which Father Roberto Busa, one of our pioneers, started to work in 1949, and then it was published at the end of the 70s. Now we have tree bank, so the syntactically annotated portion of the Index Domesticus tree bank. This is a sentence from Summa Contra Gentiles, and this is how the dependency tree is represented in the original format of the Index Domesticus tree bank. We will focus on this specific token, estimator, but keep in mind that today the Index Domesticus tree bank is available also in another schema, which is the universal dependency schema, which most likely you are well aware of, and it is today a kind of de facto standard in syntactic annotation. Okay, we will focus on this token. As we said, that the lexical resources are made of lexical entries, and lexical entries are linked to LiLa by canonical form. Instead, textual resources are made of occurrences of words. Estimator is an occurrence of word, so a token. So let's see the token estimator in LiLa, which has this URI. Again, we have this data sheet with the triples, which says that estimator, subject, as lemma, property, object, estimo. Estimator, the lemma for estimator is estimo. Okay, let's see how it works. Now we have this occurrence. This is a token, and this token is connected to the Lemma Bank. Keep always in mind that we have to link our resources through the Lemma Bank. So we link lexical resources, bicanonical forms, with lexical entries to the Lemma Bank, and we link tokens, single occurrences of words in text, to the Lemma Bank by as lemma. Estimator is linked to its lemma. Okay, and estimator, here, okay, has also the syntactic annotation. And let's see how this works. You see that there are two different representations of the syntactic annotation of estimator, because the index domesticus tree bank comes in two different schemas of annotation, UD and the original one. So this says that estimator depends on the head OC by the UD relation ACL ad nominal clause. In other words, estimator in the UD tree depends on OC by the dependency relation ACL. Instead, in the original schema of the index domesticus tree bank, estimator depends on WOD by ATR attribute. Okay, keep in mind this. Estimator depends on OC by ACL. Let's see the tree. Estimator in the UD scheme depends on OC by ACL. So this information, the fact that estimator is attached on OC as its own, and this information, the dependency relation of estimator, is what we have seen represented in LiLa. LiLa has a number of services and tools. Unfortunately, I cannot show these services and tools now because I don't have time. Just to tell you, we have a query interface for the Lemma Bank. So you can search for a lemma, and for the lemma you will see its data sheet, so all its triples and all its occurrences in corpora and all its lexical entries in the lexical resources linked to LiLa. Then, which can be maybe more interesting for you, is the SPARQL access point of LiLa. Here you can write SPARQL queries. You know, I'm used to talk to classicists, and usually classicists are very scared of SPARQL queries. You are not, I'm sure of this, but anyway, we have provided users with a number of precompiled SPARQL queries that you can just run, and maybe you can modify for your specific needs. Just now, in the last year of the project, we are working on building a nice query interface that writes the SPARQL query for you, and which allows our users to select the corpora and lexical resources that they want to use and to combine them and make queries on it. Another interesting and still ongoing, actually my computer scientist doesn't want that I show you really this, but it works, so I want to show you, and it is the text linker. Because one of the big problems, and I will come back on this now in the conclusions, is that building linguistic linked open data resources, so transforming in an RDF compliant serialization your resources is not easy, and particularly here, linking your resources and textual resources to the Lemma Bank is not trivial because you need lemmas. So the text linker is there to help people to link their raw texts in Latin to the Lemma Bank. So that text linker basically includes a lemmatizer and part-of-speech tagger for Latin, which works more or less well, but it's always tricky to say that you have an NLP tool that works well for Latin because it depends on which Latin you deal with. We have a great parser for Thomas Aquinas, 90% of label attachment score. When you apply this parser to Caesar, 27%. Another language, another lexicon, another syntax, another morphology sometimes. Anyway, the part-of-speech tagger and lemmatizer of the text linker is pretty portable on the history of Latin, and the text linker for each token tries to find which is the lemma to which that token must be linked in the Lemma Bank. Okay, to sum up and to conclude. This is the currently available resources linked to LiLa. I will not enter the details. Some of these resources maybe will tell you something, maybe the Latin wordnet. Udante is the tree bank of the Latin works of Dante Alighieri, the Index Domesticus tree bank, and the LLOD corpus is a big corpus of classical Latin, very much used by classicists. Currently, we have approximately 33 million triples that connect all these resources. So, take a look forward, challenges and hopes from infrastructures to interstructures. One challenge is to fully exploit the digital text. We have a lot of digital texts, and my feeling is that we exploit them not at their best. In particular, in the literary world, in the humanities world, sometimes resources are queried one by one, searching maybe for just all the occurrences of a lemma, which is great, but it's not enough. We can do much more than this. One big challenge is making LLOD linked open data more accessible and usable, facilitating wider participation in LLOD by automating the processing of metadata creation, which is exactly what we are doing, for instance, with the text linker and what the PretaLLOD, which comes from Pret-à-Porter project, wants to do. So to create an easy way to build LLOD resources. And this is very important in an infrastructure like CLARIN, where you have a lot of wonderful resources for a number of languages. And what is still missing is to make them interact. This is the reason why our aim is to build a so-called resource family in CLARIN devoted to interoperability in linked open data in CLARIN, moving from infrastructure, what is CLARIN now, to interstructure, what CLARIN maybe will become. Because building LLODs is great, but it takes money, time, and expertise. So we need funding for this, and CLARIN is starting to support us to go towards linked open data in the infrastructure. There is a lot of things to do. If there are PhD students there, I have a lot of ideas for PhD thesis, and one of these is building models for representing linguistic data and metadata, but not only linguistic. For instance, all the word of philology is still missing from what is ontologies. And you know that linked data is a community-based effort. So we have to persuade users and developers to use the same practices and the same vocabularies, ontologies, and data categories. Because keep in mind, and this is my, let me say, last message, that if we want that resources interact, we must interact in the sense that we must use the same vocabulary for knowledge description in order to make resources speak the same language. And I thank you very much again for this invitation. I hope that my talk was not too boring, and I'm very sorry that I'm not there with you, because I'm sure that I would have enjoyed so much these days in Lugano, and I miss Lugano very much. I lived there for a couple of years. So thank you very much.
Okay, do I have any questions from the audience? Well, then I'm going to start off. So you touched on how Latin changes across the centuries and how that poses a lot of challenges in terms of NLP. But how did you deal with that when you created the tool? How did you deal with the changes over centuries in Latin? You know, you got over 2 millennia of changes, diachronic changes. So how do you deal with that?
Well, this is a big question. It's a big question that I will summarize very briefly. Please, first, keep in mind that we have this challenge, this shared task that happens every 2 years that is called Eva Latin. You know, in Italian we have Evalita, which is a campaign of evaluation of natural language processing tools for Latin, Eva Latin. The next edition will happen in 2 weeks at El Rec in Marsiglia. Maybe some of you will be there. And one of the subtasks of EVA Latin is the cross-time subtask. So you train a tool on classical Latin, and then you apply this tool on documentary late medieval Latin, and you see what happens. So your question, and this gives you an idea of the performance of the tools. And it's also interesting because the errors that the tool make give you an idea of in what is different one Latin from the other. But you said, how did you deal with this? Especially for the text linker and for the part-to-speech tagger and lemmatizer that is implemented there, we used a very large training set comprising texts from classical Latin, from medieval Latin, for very, let me say, early Latin, new Latin, and covering different genres. Because even genres are show a wide diversity. So we have poetry, we have prose, we have documentary text, historical text, literary text, all this stuff. At the level of lemmatization and part-to-speech tagging, performances do not drop so much. You can look at the overview of the first EVA Latin if you search in Scholar for Passarotti overview EVA Latin. Of course, when you come to syntax, dependency syntax in particular, as I said, with the example of Thomas Aquinas and Caesar, performances drop much heavily. And basically, we have not dealt with this yet, because even applying domain adaptation techniques does not give us good results yet.
Thank you so much. Are there any questions from the audience? Yes, there is a question over here.
Hi, you mentioned such poor performance. I was just wondering if you use neural networks, use machine learning to train your models? Have you tried?
Yeah. Yeah, sure. We tested a number of different tools, and the one that was performing best was the UDPipe. Maybe you know about UDPipe. Is a pipeline of NLP tools developed in Prague, and UDPipe makes use of neural networks, but most of all, it makes use of word embeddings. Today, everyone talks about word embeddings. They are much used. They are available also for Latin, and UDPipe makes use of word embeddings. We have built two sets of word embeddings for Latin, one for Thomas Aquinas, one from classical Latin, but the birth Latin embeddings are the ones that provide the best solutions, and this is what is used by our model built in UDPipe.
Thank you so much, Marco. Do I have any other questions from the audience? Yes, I do see a hand over there.
Hi, so how do you handle the sense changes across the time, like the word senses that you store? So the senses of the word can change across time, right?
Yes. So actually, LiLa reflects the information that is stored in the already available resources. So if the Latin wordnet assigns 5 lemmas to a specific synset, we reflect this in LiLa. We do not make any, let me say, any critics of this. As for the resources, there is a big problem here in word sense disambiguation, because several words are assigned several senses. And in dictionaries that we reflect in the traditional lexicography of Latin, you have several senses that sometimes refer to different chronological spans of Latin. So we have not dealt with this yet, because we just represented the different senses with no further markup. But I plan in the coming years, especially now that we are going to include the Thesaurus Linguae Latine in LiLa, to assign some specific markup of the age of a specific sense for Latin. But again, I'm not really a lexicographer. I reflect what the lexicographers say in their resources, and if they say that sense A is classical and sense B is medieval, my task is to represent this information in LiLa, which is something that we have not dealt with yet. And the big problem is that word sentence disambiguation is still completely missing for Latin. We do not have yet corpora with word sentence disambiguation for Latin, which will be very, very helpful. And yesterday I heard a talk by Roberto Navigli, who did a great work on word sentence disambiguation for several model languages. And this is exactly what we must do for Latin. So if there is some PhD student there who wants to work on word sentence disambiguation for Latin or on domain adaptation across time for Latin, this is a very challenging task. Thank you for the question.
Thank you, Marco. Are there any other questions from the audience? We do have a little more if you're willing. If not, well, let me thank Marco again. Thank you so much, Marco. And please, let's thank our speaker.
Grazie, grazie molte. Thank you very much. Enjoy the conference without me.
You.
And I'm very sorry that I won't be there, but enjoy it. I'm sure that you will do it. Grazie. Ciao.
Grazie, Marco. Thank you. So